Okay, so we are on lesson 7.8 for Algebra 1. Today we're going to look at multiplying polynomials. In the last lesson, we looked at adding and subtracting polynomials. I will tell you we are spending 2 days on lesson 7.8, so if it seems like it's a little bit trickier, that's okay. Don't panic. We are going to spend 2 days on it. So let's do our warm-up first. Make sure we're on the right page. Let's see if I can scroll up a little. Yeah. There we go. Okay, so we know that 3 squared, 3 times 3 is 9, so that should be an easy one. 2 times 2 times 2 times 2, so this we know is 4, this we know is 4, so 4 times 4 is 16. 10 squared, so 10 times 10 is 100, not 1,000, 100. Okay, for number 4, we just need to simplify. We don't have to carry it out. Remember, if we have the same base, we add the exponents together, so that becomes 2 to the 7th. Again, same base, we add the exponent, so that becomes y to the 9th. If there's a power raised to a power, we multiply, so that becomes 5 to the 6th. Again, we multiply the powers, so x to the 8th. And then if we have a number out in front of parentheses, we distribute, and you have to distribute the sign. So negative 4 times x becomes a negative 4x. A negative 4 times a negative 7 becomes a positive 28. So be careful with your signs. Okay, so we're going to look at multiplying polynomials. Multiplying monomials, meaning one term, and polynomials, meaning 2 or more terms. You'll use some of the same properties we did with exponents, which we learned earlier. So just don't forget things we've learned already. Okay, so we're going to first multiply 2 monomials together, meaning just things with one term in each. So we got to make sure that we distribute everything. So we're going to multiply the 6 times the 3 first, so that becomes 18. And then y to the 3rd times y to the 5th, we're actually going to add the exponents together since they're the same base, and we're at multiplying, so that becomes y to the 8th. Okay, on this next one, we're going to multiply the coefficients first. So 3 times 9 is 27. Then my m times m squared becomes m to the 3rd because I'm adding a 1 here and a 2 here. Then my n's have the same base, so I've got a 2 and a 1, so those add together to become n to the 3rd. There's no c. I don't know why there's a random c sitting there. Just remember, when you're multiplying powers with the same base, you keep the base and add the exponents. And to multiply a polynomial by a monomial, you use the distributive property. Okay, so we're going to now look at multiplying a monomial by a polynomial. So monomial means mono, one, and then a polynomial means more than one term. So for this first one, we've got a 4 outside of the parentheses, so we need to distribute that 4 to each term. So 4 times 3 becomes 12, and we keep the x squared. And then 4 times 4 becomes 16, but we keep the x. And then 4 times negative 8 becomes negative 32. Okay, with b. So we're going to multiply the coefficients first. 6 times 2 is 12. Now we've got to multiply the pq times p. Well, we've got a base of p, a base of p, so we add their exponents, so that becomes a 2. And then there's no other q, so we just leave the q there. Okay, and then 6 times 1 times negative 1 becomes a negative 6. And then we've got a pq times a q, so there's no other p's, but there is another q, so we add those exponents together and get q squared. So again, I'm distributing every part of what's out in front to every part of inside the parentheses. Okay, so on C, we're going to distribute the 1/2. 1/2 of 6 is 3. Then we've got the x squared times x, so we add the exponents, so it becomes x to the 3rd. The y times y, there's a 1 on each of those as an exponent, so that becomes y squared. Plus, I've got to distribute the 1/2 to the 8, so 1/2 of 8 is 4. X squared times x squared becomes x to the 4th. I add the exponents. Y times y squared becomes y to the 3rd, because again, I have to add the exponents. Okay, so now it's here. This is where you really need to pay attention. We're going to look at multiplying a binomial by another binomial. So 2 terms, so this says 2 terms, times another 2-termed polynomial. Okay, So we're going to apply the distributive property more than once in this case. So what you do is you start by multiplying this term by each of what's inside here, and then the second term by each of what's inside here. So they're splitting up the x and the 3, and they're distributing it to everything inside of the second parentheses. I think this gets a little confusing to do it this way. So what I like to do, let me erase this. No. Bear with me. Okay. So what I like to do is I like to take the first term and multiply it by the first term here, and then multiply it by the second term. So that becomes x squared plus 2x. And then I take that second term and multiply it by this first term and this second term. So that's 3 times x is 3x, and then 3 times 2 is 6. And then I can combine like terms and get x squared plus 5x plus 6. So if you want to break it up how they do in this example, you can. I think that gets a little confusing sometimes. So I'm going to kind of walk you through it this other way, which it's essentially doing the same thing. Another method that we use for multiplying binomials is called the FOIL method, which is what I was just explaining. It's where you take the first term, so f for FOIL. F, we take the first two terms, so the first terms of each, and we get whatever that is. Then you take the outer terms, so the outer terms, O for outer, and whatever those multiply together to, you have that. Then you take the inner term, okay, so I for inner, and you get that term. And then you take the last term, L for last, so the two last terms, and you get that. So you've got 4 terms, FOIL, F-O-I-L, first, outer, inner, last. And once you have those, you would combine any that are like terms, and usually the outer and inner combine, not always, but in this case they do. So they combine to make 5x. So like I said, if you like doing the method here, you can, but what I did over here was actually the FOIL method, which is explained right here. If you have an expression like x plus 5 squared, they're telling you that you're taking x plus 5 as your base and you're multiplying it by itself, so you're squaring it. So just know that you're multiplying x plus 5 times x plus 5. So that would get distributed first, which is x squared, outer, which is 5x, O, or I, which is inner, and then last L, which is 25. And then we would combine our O and our I, our outer and inner terms, so that becomes x squared plus 10x plus 25. Okay, so let's walk through these. So we're going to take, let's write this up here, FOIL. We're going to take our first term. So first term becomes s squared. We're going to do our outer next, our 2 outer terms. So that becomes a minus 2s because I've got a minus 2 here. Then my I is my inner, so that becomes 4s. And then L is my last, which is the last 2 terms, is a negative 8 because it's 4 times negative 8. So now I have s squared. My negative 2s and my positive 4s just become a positive 2s minus 8. Okay? All right, let's look at B. So I've got x minus 4 squared. Now remember it said if it's taking x minus 4 squared, that means x minus 4 times x minus 4. Okay? We're going to do our first, our f, s, which is x squared. Our O, which is outer, so negative 4x. You've got to keep that sign with it. I for inner, minus 4x. And then last, L, positive 16 because it's a negative 4 times a negative 4. Now we can combine our minus 4x and a minus 4x, which becomes a minus 8x plus 16. And you're done. Okay, now we're going to do the same thing. First, so 8m to the 4th, because we're going to add the exponents, plus or minus 24m squared n. We can't combine these, they're just multiplied together. Then we have our inner, so that becomes a minus m squared n. And then our last, a negative times a negative, is a positive 3n squared. Now if you look, I have a minus 24m squared n and a minus m squared n. So I've got minus 24 minus 1. So that becomes a minus 25 m squared n plus 3n squared. If we're going to multiply more than two terms, you can use the distributive property several times. So for example, if I have a binomial times a trinomial, you can take each of these terms and multiply it by each of these terms, and then the second term, multiply it by each term. You've just got to make sure that you carry out every part of it multiplying together. You can also use a rectangle model. You guys have probably seen this to multiply polynomials with more than two terms. This is similar to finding the area of a rectangle with length and width. So what you can do is if I'm multiplying this polynomial by this polynomial, you can set them up across the top and then along the sides, the terms, and then you're basically using like a multiplication table to multiply and get what's inside. And once you have everything inside, you would combine all the like terms and write it out as is. Okay, so let's try one. I'm going to do it by using the distributive property. So I'm going to take the first term times this first term. So x squared times x is x to the third. Then x times 4x is 4x squared. And now this to the last one. So that becomes a minus 6x. Now I've got to take the second term minus this first term. So minus 5x, because it's a negative 5. Minus 20x, because I've got minus 5 times positive 4x. And then minus 5 times minus 6 is a positive 30. I've got all of these terms, so now I've got to look for any that I can combine. Okay, there's no other x cubed, so I'm just going to write x cubed. I've got a 4x squared here, and I've got no other 4x or no other x squared, so I've got 4x squared. Okay. Then I'm going to take my minus 6x, my minus 5x, and my minus 20x, which becomes minus, did I do something wrong here? No, just want to make sure. Which becomes minus 31x, and then I've got my 30 left over. And we are all done. Okay, so you've just got to make sure that you combine everything together that goes together, if that made any sense. Combine all your like terms, is what I meant to say. Okay, let's try another one. So I'm going to take this first term and multiply it by this first term. So minus 8x cubed, because I've got an x here and an x squared. That times this term, so minus 20x squared. This times that last term becomes a positive 6x. Then I've got minus 5 times a minus 4x becomes a positive 20x squared. Minus 5 times minus 10x becomes a positive 50x. And then minus 5 times positive 3 becomes a minus 15. Okay, so now I've got to combine all of my like terms. Well, I don't have another x cubed, so I've got a minus 8x cubed. Okay, I've got a negative 20x squared and a positive 20x squared. Well, since they're opposites, when I add them together, they cancel out. Then I've got a positive 6x and a positive 50x, so that becomes plus 50x. And then I don't have any other constants, so that's a minus 15. So this is the answer to that one. Okay, for C, I'm going to work this out over here. We're taking x plus 3 squared. So x plus 3 times x plus 3. So I'm going to take my first term, x squared, my outer term, 3x, my inner term, 3x, and then my last term, 9. I'm going to combine these two terms since they are the same, so that becomes plus 6x. and then I leave my 9 and my x squared, and you are done. Again, you can use this box method if you like. You're basically taking this first one and you're writing it down along the side. So we've got a 3x and a positive 1. And then here we're taking the x cubed, the positive, oh, they wrote that wrong. That should be a positive 4x squared and a negative 7. And then when you multiply this, you're basically taking the 3x times the x cubed, which becomes 3x to the 4th. Then the x to the 3rd times the 1, which becomes x to the 3rd. 3x times 4x squared, this should be a positive. They messed that up. Unless they wanted this to be a negative. I don't know if they messed that. Maybe they messed that up. So yeah, you're just taking this just like a multiplication table, and once you have all your terms written out, you can write them out and then combine anything that's the same to get your answer. Okay, it doesn't matter to me if you want to do it, you know, writing it out like this, or if you want to do it in a table, that's fine, whichever you prefer. This might be helpful. When you have a polynomial with however many terms it has multiplied by another polynomial with however many terms it has, your product before it's simplifying will have the number of terms of the first times the number of terms in the second. So for example, that last one that they showed us, they had 2 terms in this first one, 1, 2, and 3 terms in the second, 1, 2, 3. So your answer should have 2 times 3 terms. So 2 times 3 is 6. 1, 2, 3, 4, 5, 6. That is, again, before simplifying. Okay? Before you combine like terms, it'll have that many. All right, we've got one word problem and then our practice quiz, and we are done. All right, the width of a rectangular prism is 3 feet less than the height, and the length of the prism is 4 feet more than the height. Write a polynomial that represents the area of the prism, the base of the prism. Okay, we know area is length times width, so we've got to figure out what our length is and what our width is. Well, they tell us that the length of the prism is 4 feet more than the height. So we don't know what the height is, so we're going to call that h, and we're going to say h plus 4 for the length, because the length is 4 feet more. The width is 3 feet less than the height, so it's h minus 3. Okay, we don't know what those are yet. We haven't been told the height. So to write a polynomial, it's going to be area is length times width. So it's going to be h plus 4 times h minus 3. So I'm going to use our FOIL method. So first is h squared, outer minus 3h, inner 4h, last minus 12. I'm going to combine these two terms, h squared plus h minus 12. So this would be my polynomial. A polynomial, again, is anything with 2 or more terms. So we've got 3 in this one. And now it says, what would the area be if the height was 5? So we know the area is this polynomial. So they want to know what would the area be if the height was 5. So we're going to plug 5 in for all of my h's. So 5 times 5 is 25, plus 5 minus 12. 25 plus 5 is 30 minus 12. 30 minus 12 is 18. So your answer is 18 square feet. But part A wanted you to find the polynomial. So it was taking the length times the width. Okay. Try, please, for me right now, pause this and to try to do these problems before I give you the answers. Okay? I'm just asking that you do that. Okay. So we're going to start by multiplying everything in this by everything in this. So we're going to have 18. My s's become s cubed. My t's become t cubed. I've got to distribute. So I've got 4x squared, because y squared, because I've got an x and an x, plus 4xy cubed, because I've got a y and a y squared, but I keep that x. Okay, we're going to use our FOIL method. So first, x squared, outer, 8x, inner, 2x, last, minus 16. I'm going to combine my O and my I, my outer and my inner. So I've got x squared minus 6x minus 16. So this is my final answer, simplified. Okay, I'm going to take this one times every term in here. So that becomes 2x cubed plus 6x squared minus, because it's a minus 4 times 2x, minus 8x. Now I'm going to take this term times everything, minus 7x squared minus 21x plus 28. So now I'm going to combine any of my like terms. There's no other x cubed, so 2x cubed. I've got a negative 7x squared and positive 6x squared, so I've got a minus 1x squared. You could just write minus x squared if you want. And then I've got a minus 8x and a minus 21x, which becomes minus 29x plus 28. So this is my simplified answer. Okay, I'm going to distribute this to every term in the second polynomial. So I'm going to have 6m cubed n, because this is 1 and this is 2. Then I'm going to have 60m squared n squared, because I've got a 1 here, a 1 here, a 1 here, a 1 here, and these multiply together. And then I'm going to multiply 6mn times negative 2. So that becomes a negative 12mn. And these nothing can be combined, so your answer is done. Okay, last one, we're going to do the FOIL method. So first, FOIL, first, outer, inner, last. So first is 6x squared. Outer is 2xy. Inner, minus 15xy. And last, minus 5y squared. Combine any like terms, so 6x squared minus 13xy, because I've got a minus 15xy and a positive 2xy, and then my last term minus 5y squared. Okay, so again, you guys, I know this is a little bit of a tougher lesson. That's okay. We're spending 2 days on it. We'll get lots of practice. So just ask lots of questions on your homework.